Hey everyone, hope you're doing well. Welcome to Time to React. It's been a little while since we got to see you guys. Took a little bit of time off over the summer, doing a couple of other events and things like that. But yeah, we're back now doing our favorite Time to React. So I hope you're all good. I've got a really cool event for you this evening. Really grateful to our speakers, Elliot and Kannan, for coming on board, and thanks to the guys from Simply Business as well for being able to help us out with the marketing of the event and everything. So a lot of you guys might know Elliot. He's spoken at quite a few of our events in the past. He's one of our most seasoned speakers, and what I'm sure he doesn't want me to tell you as well, he's actually got the most views on any of our views up on the Pusher YouTube channel from a previous Time to React event. I think it's almost 10,000 views that it's got at the moment. So expect big things from him. No pressure, Elliot, but he'll be coming up first tonight for his topic, which is static callbacks with React hooks, what class components did right. So I think Elliot's done a React hooks topic for us. He's actually written a blog as well recently, and I think he'll probably be referring to that blog in his presentation. But what I think I've shared it on LinkedIn, but I will also put a link to it in the comments section in just a second. So after Elliot, obviously you can get involved in the Q&A. So just write down in the comments section any questions. You can write them down during the presentation if you like as well, and then we'll come to them at the end, and we'll be able to answer all of those for you. But yes, it's obviously a live event, so feel free to ask away. Then we'll have Kannan. He'll be speaking to us about React Atomic, so data-driven dynamic design elements with plug and play. So yeah, I mean it's like obviously a pretty big subject and a new element of the technology. So yeah, Kannan works at Simply Business. Simply Business have sponsored our event a couple of times in the past. I don't know if any of you guys went to their really nice offices, but yeah, it's obviously a while since anyone's been in their offices, I imagine. But once things go back to normal, it's a great place to work. They are hiring. They're quite often hiring. So I know that there's a couple of their guys who are listening along to this as well. So if you did have any questions about what Simply Business might be like, then you can always have a chat with those guys. But Kannan, yeah, he's a first time speaker for us, so really grateful to him to take the time. It's not easy doing this, particularly when you're just speaking to your laptop, even though we are a big community. So I'm sure you'll all make him feel nice and welcome. And then obviously after his presentation as well, there will be opportunity for another Q&A. So both of our Q&As are going to be a bit of a panel discussion. So Elliot and Kannan will be present for both of them. So if you miss out on the opportunity to ask Elliot a question, you can ask it during Kannan's Q&A. And then obviously Elliot will be there to sort of lend his opinion. They'll each be there to obviously lend their opinion on each other's presentations. So Elliot will ask Kannan some questions and Kannan will ask Elliot some questions as well. So it should be really cool. So look, I'll shut up now. So thank you guys all for taking so much. And just to explain this, by the way, people sometimes think that I'm in a sushi shop, and so I'm not in a sushi shop. It's just a room divider. So my working from home setup at the moment, my fiance gets the really nice table with a big window in the lounge room, and I get the bedroom. But I've got this very nice room divider behind me, so that explains it a little bit. So I'm sure there are worse working from home situations though, so I'm not too unlucky. But look, I hope you guys enjoy the event. I'll be in the comments section throughout as well, and on the Q&As. So if you've got any questions or anything like that for myself as well, just yell out. But hope you guys really enjoy it, and we'll crack on with our first event.
Hello everybody, my name is Elliot and I'm from a company called Hyperexponential. My talk today is on static callbacks in React hooks, but just a quick note on Hyperexponential. We're a small insurtech, fintech startup, usually working in South London, but a bit all over the place at the moment. We deal with some really interesting problems using some really interesting data sets that most people don't kind of realize exist. And we have a lot of talented people internally and are always looking for more. So there'll be an email at the end that you can send a message off to if you're interested to join us. But my talk today is on static callbacks and React hooks, and specifically what I think class components did right. And I should probably preface this by saying a few things about class components and functional components. So I really don't like class components. I think there's too much boilerplate. They can be really difficult to read when they get large, and they're very tricky to split up and abstract. You can't really share functionality very easily. In comparison, I really like functional components with hooks. There's less syntax and boilerplate, or at least it's a lot more understandable when there is. It's really easy to split up and abstract with custom hooks, and you can make large components really easy to read that way by just splitting up certain functionality and sharing it or putting it in different files and turning your really long components into a really short and easy to read small ones. And of course, there are many, many more, the effect system, etc., etc. I won't go onto it right now. But there's one thing I really don't like about functional components with hooks, and that's the use callback hook. And I think actually it's quite a lot worse than a class method. And the main reason for this is something called reference equality. And if you've seen any of my prior talks, you'll know that I tend to bang on about reference equality a little bit and optimization. But to me, it's really important. And for building really big and complex optimized apps like we do internally at Hyperexponential, it does become very important. So when you have a class method, the reference is constant for the life of the class. And it can always access the most up-to-date props and state. If it uses a prop or a state, it just uses the most current version of it. There's no chance of it going stale. Whereas a use callback hook, well, its reference changes every time a dependency changes. And if you want to use props or state inside the hook, you need to add it to the dependencies to validate rules of hooks, and so that it doesn't use a stale version of it. But that means the reference is going to update every time that dependency changes, which means there are going to be more updates the more dependencies that you have, and this starts to get really out of control. But before I dive too far into that, I'm just going to talk about what I mean by reference equality, because some people might not be super familiar with it. So, quick sidebar. Booleans, strings, numbers, null, undefined, all primitive value types in JavaScript and TypeScript are all compared with value equality, which means that you say, is true equal to true? Is string A equal to string B? Whereas objects and functions are slightly different. They're compared using references, which doesn't necessarily mean are they the same thing? Do they equal the same thing internally? It's about, are they the actual same instance? Is it the same object? Object A and object B might have the exact same contents, but they might not be referentially equal if they weren't actually the same object. And functions are very similar to this. They also are done by reference equality, but it's a lot more difficult to check whether the contents are the same in a function. You can write a deep equality check for objects, and that will check value equality. The horrible and don't do this way of doing it is JSON stringify. That takes a very long time, but for you can write some pretty optimal equality checks. Just the worst case time is when they are the same, because you have to check literally every key value property pair. You can't really do the same with functions. It's really quite a bad idea and very difficult, because you essentially need to write a test suite that you're going to run every time you get a reference update to say, does this function do the same thing as its past version? And actually, if the function's side effecting, you can't run that safely without causing some code to affect that maybe you didn't want to execute that function if it was the same, so it just wouldn't work. And it's generally quite a bad idea. So, that said, why does reference equality matter in the terms of React components? Well, if you've got a component that re-renders, and it can and often should trigger re-renders of its children. But sometimes you might not want it to. Sometimes its children haven't actually updated at all, or don't need to update, and they should just be left as is, and we can cut the tree there and stop the updates propagating down. And in class components, there was an internal method called shouldComponentUpdate. And we could just write things as pure components, which would basically instantiate a shouldComponentUpdate method with a shallow equality check. But we could do a memo around a functional component as well, if we really wanted to. And this is actually really great. And a lot of the time, really helps with a lot of optimization problems because it does that shallow reference equality check. It says, okay, is this string equal to this string? Is this object the same as this object? It's slightly less useful for identical objects or functions with different references. It means that you have to memorize your object higher up in the tree. But for functions, especially functions without static references, it's basically useless. It doesn't do that optimistic update step, and it can really screw up all your fancy optimization work. So let's take a look at an example. Here we have a dialog manager class. This is just a class that's going to wrap around some custom dialog component that we want to share about. It's pretty dumb and just needs all of its external information passed in. But we might share the internal dialog around that you can see in the render method, but we're going to control its state from outside. And that general dialog component might take an open state, it might take a warning state, it might take a title, and it, in this case, takes an onSubmit callback. So perhaps there's a button inside where when you click it, it fires that onSubmit, or maybe when you hit enter on a text field inside, that would fire the submit method. So our manager needs to provide that to it. Now this manager in this case has a prop called update server that maybe it needs to send some data to, and it has some state. It has the open state, the warning, and maybe an internal value that it's going to use for some stuff. We initialize all that in the constructor, and then we have functionality to control the open and close and warning states and any other functionality within the constructor within this class. And we're going to ignore that for now. What we really care about is the submit that we pass down. So we've got this onDialog submit method, and this uses that props.update server and uses state.value, and so it always wants to use the most up-to-date version of those props and state to fire. And when the method is instantiated at the construction of the class, its reference is created and then just left. It is static for the lifetime of the component, which means that the dialog doesn't receive a different onSubmit prop ever. It gets it once and it is static. And that's great. So now that dialog is just only going to update if state.open, state.warning, or the title changes. Let's take a look at that as a functional component. Well, here we have it as a functional component with hooks, and it's broadly the same. It still takes the update server prop. We're using the same internal state, it's just set in a more split out, hooksy kind of way. We could do this with a single use state with an object pattern, but here it's more clear, I think, and we're not really using it anyway. We map across the same functionality to control open, close, and warning states, but where the crucial difference lies is in the callback. So we have this onDialog submit that now is a use callback that calls update server with value. Well, now we have to put that update server prop and the value piece of state into the dependency array. Otherwise, we'd be using stale versions of it, and the callback wouldn't be particularly useful at all. But this means that that onDialog submit will update whenever update server or value changes. With value, this could be changed very frequently whenever a keystroke is pressed. And update server, if it's not a referentially stable callback coming in from above, then that could be updating really frequently and propagating an update down the tree that we don't want. So we've got a problem here, that maybe that dialog might change and it might re-render when it hasn't actually had anything that it needs to change for, only on submit that previously was pretty static. So React is built along this principle that your view should be a function of your data. And I also like to think of the fact that really a component should only re-render if it has new information to show to the user. You're talking about conveying information to the user with a view. So given that, why would this update? Why should this update? Well, the dialog should update if the open state changes, or if it gets a different warning state. Maybe it needs to change its background color to red, or it needs to put a little warning message on. Or maybe if the title changed, here it's static, but maybe that title could be dynamic and we want that to change. But probably it doesn't need to update when the onSubmit changes. But in this case, it will, whenever that update server or that value changes. And this is annoying because we had this behavior before with the class component, but now we've lost it. And now we're getting more updates than are necessary. So it sounds like what we want is callbacks with static references that always use the most up-to-date functionality. Well, okay, great. Well, will this actually work? Because our use callbacks are kind of dependent at the moment on having dynamic references. Well, let's take a look. Why do we need callbacks? Broadly, there are 3 reasons, I think, that we're going to write a callback function. The first is when we pass a callback to a child component. We might also use one as a way of sharing functionality between multiple other callbacks that we pass to child components. So if we've got multiple things that we're sending in, we might just not want to reuse and rewrite all that functionality and just put it into a single spot that we can share about. And we might write a use callback for that so as we don't break our dependency cycles. And as a way of sharing functionality between several use effect hooks, maybe we've got the same situation with many use effect hooks and we want to have the same actual function happening. Okay, let's go through these one by one and see if they would work with a static callback. Passing callback to child components. There's no real way of inspecting what a function does from its reference. So if you get passed a function as a component, you don't really know what it does aside from its name. And yes, at runtime you can pick its name out if it's got one defined, but that's kind of it. And since you don't really get any information about it at runtime, when it changes, you also really can't get any information about it, aside from the fact that maybe its functionality changed, but it might not have done. Actually, it might still do the exact same thing, but still had a reference update. You don't know. So if you want to convey anything meaningful to the user about what a function does, or what a button is going to do when it is clicked, you kind of need to pass other props. You need to pass some text for that button. You need to pass a color for that button. If the button goes from a submit to a cancel, its function will change, but you don't know that from looking at the function. You have to pass a text prop that says submit or cancel. You have to pass a color that says green or red. And so if you can say, okay, well then maybe we don't care about that reference changing. The proof for the second case for the shared functionality callbacks is really an induction proof upon this. You just have to say, if I don't care about a reference changing for a callback that I'm passing to a child, then that callback can be static, which means any function that it uses can have a static reference, as long as it uses the most up-to-date functionality. So those two are really easy. Effects are slightly more difficult. Here we have some code that has a callback, so some shared functionality that we're going to use in an effect. And the callback uses some callback dependencies, which because we're good and we obey laws of hooks, we have put into the dependency array. We then have an effect. And that effect says, right, if some check, call the callback. And following the rules of hooks, we should be putting some check and callback into our dependency array. That's fine. And in this case, what will happen is that effect will fire whenever some check changes or any one of the callback dependencies, because any one of the callback dependencies changes updates that callback reference, which then will update the dependency array of the effect. And that's good. Sometimes we want that. The annoying thing is, though, sometimes you don't. Sometimes you actually just want that effect to fire whenever some check changes, and you just want it to call the most up-to-date functionality, but you kind of can't because your callback is now firing too frequently. So you might need to use refs or hack around it, and it gets really annoying. So sometimes that's actually not the functionality you want. But assuming that is, and assuming we have to preserve this functionality with static callbacks, how can we do it? Well, let's assume we have the same code, but with a static callback. So our use static callback here does exactly the same thing as the use callback before, except it doesn't need a dependency range because its reference never changes. It's always just going to call the most up-to-date version of itself, but it's going to have a static reference. To get the same effect with the use effect, all we need to do is just take the callback dependency that we had, the callback dependencies that we had before, and spread them into our dependency array. Then that effect will fire whenever some check changes or callback dependencies change. So great. That's really useful. But what's even more useful is now we could actually take out callback dependencies and we wouldn't be breaking rules of hooks. Yes, we'd need to put the callback reference in there, but since that's static, we know that it's not going to change and affect the use effect and actually update it more than it needs to. So it's fine. It's just a stale piece that needs to go in there to satisfy your linter. But that means that we can actually have a use effect that only watches the check and then just calls the most up-to-date functionality using any dependency it wants without actually breaking any rules of hooks. So this is great. So it seems like we don't actually need dynamic callbacks, and they only really make things worse. So how do I write a static callback? Well, there are a few ways. You could use refs for things that you use inside the callback. Say you have some props or some state. You could create a ref with an object in it and assign the props and state into it every time the render runs, and then go into your use callback and just pick it out of the ref. And that would work, and that's a good workaround. The problem is that every time that you want to make a callback static as opposed to dynamic, you'd have to do that. And that's a lot of code, and it's a lot of boilerplate to keep rewriting. What we'd really like is something like in that prior example where we just had use static callback and it just worked. Well, yes, we can do that because one of the wonders of Hooked is writing custom hooks. So let's write a custom hook. And because it's 2020, let's do it in TypeScript. So here is one. Here's use static callback. And this is going to do some nice things like infer the result type based on the type of the function that you pass in. But crucially, what it does is it takes the callback that you pass in each time that it runs, so on each render, and it stores it in a ref. And then what it returns is a use callback with an empty dependency array. That's why we want to be looking for empty dependency arrays, because empty dependency arrays mean that the function won't update. It means that it will have a static reference. And inside that callback, we call the current of the ref and pass it the arguments through. And what this means is we get a static reference to a callback that always updates with the most current functionality. And that's great. That's exactly what we want. Now, all this being said, this won't fix every problem that you have. And truthfully, this is an optimization. And a lot of times, you don't need an optimization. They're not inherently right or wrong. It's really how you use them. And premature optimizations are the death of any good code base. So make sure that this is a problem that you're finding. Make sure that this is something where you find a update that is being spiked down from some callback that needs to get passed heavily through the tree. And then take it out. But don't try and fix a problem you don't have. And secondly, writing software is complicated. There will be edge cases where static callbacks don't work for you. I'm of the opinion that many of those can be solved in other ways, and actually static callbacks would be really great here. But that's a debate that we can have in the question session or in the comments below. So if you have a question, please do share it. And there is a supporting blog for this article that you can find at medium.com/hyperexponential. But thank you very much. I've got the blog link there. And also, as I said at the top of this talk, we are hiring. So please get in touch at hello@hyperexponential.com. Thank you very much.
Standard. I put myself on mute, which I think for the next one I'll get a t-shirt that says you're on mute. So Elliot, that was awesome. Great speech. So well done. How does it feel doing it remotely compared to usual?
Yeah, it's very strange, especially when you can't see people, see reactions, and don't know how long of a gap to lead at any point. But yeah, fun, interesting.
Yeah, the jokes don't work quite so well, do they? I found that out the hard way.
Also, I can't throw ducks out to people now, so.
Yeah, yeah, exactly. It's a shame. I've actually got some of your ducks here, so I'll have to go get them. Cool. So yeah, obviously, hopefully we'll get some questions coming through. So guys, if you do have any questions, obviously just fire away in the comments section, and Elliot and Kannan will be happy to answer. But Kannan, thanks very much for you as well to joining us this evening. So did you have any thoughts or questions on Elliot's presentation?
Yes, I do have a couple of questions. First one is there any edge case we need to worry if we use static callback?
So I sort of, while writing the blog and doing and converting it to a presentation, I kept trying to say, well, basically what are people going to come up with an edge case that's going to completely invalidate the whole proposal? The one I've thought of is if you sort of have something like a get text function, say that you pass to a child, where actually it's a function that gets called during the render to actually say what is going to be part of the child DOM. There are reasons why you might have that pattern. I wouldn't think that it's necessarily a good pattern to have, but in that case, then you wouldn't want a static callback, because if you did update the functionality of the component, you wouldn't necessarily know to recall it, especially if you memoized it within the child component. So yeah, that would be a very weird pattern. I don't use that sort of pattern, but that was one that I kind of came up with. Aside from that, I think I mentioned it in the talk. It's with class components, everything was a static callback. So if you have new functionality that suddenly this would break, it's probably because you've started writing it as a result of a hook pattern.
Makes sense.
Great.
Yeah. The second question is, can we use use event callback rather than using use static callback for reading an often changing value from use callback? Can we?
Yeah. So you're a man who has read the React docs very thoroughly. For the two places that is mentioned. Yes, and it's essentially the same thing, really. It's they have got some nice bits of error catching in there in case you fire an event handler during rendering. They also update their current property in their use static callback. Essentially, they call it use event callback in an effect, which I'm not sure is entirely necessary. And also they use a spread parameter in the dependency array, which I think they say not to do as well. So yes, and that would absolutely work. It's fundamentally, I think, doing a very similar job.
Thank you. Thanks, Elliot.
Great. So you might have touched on this question just a little bit, but if you could expand a little bit. We've had a question in the comments section from Alexander. So he says, what is the best case to use static callback?
Yeah. So where I started bumping into this problem was when I had some very deeply nested components that, by the way that they sort of got built, I had a button very low down, but I needed the control and all the state for that button very high up. And I didn't want to prop pipe all that data down so that it could be handled at that button level. So I ended up having a callback at the top that I wanted to pass all the way through. So that is one case. The other case is when you have that sort of pattern, or maybe it's only a couple layers deep, where you have a very large dependency array and you know that callback is going to be updating a lot. Those two things can really cause a bit of a perfect storm in terms of bottlenecks. But the best case to use it is where you work out that a function is causing a lot of unnecessary updates. If you don't have a case where a function is causing a lot of unnecessary updates, then it's an unnecessary optimization, and that's probably more of a waste of your time to implement than you're going to get the benefit out of. I hope, yeah. Where it's a bottleneck for the problem.
He's expanded on it a little bit more. So a question from Alexander again, just saying, what about using pure components?
So yes, so the issue with pure components is that issue of reference equality. So when you're passing a function callback to a pure component, it's not looking at what the function does, it's looking at how often the ref is updated. So if that function doesn't need to have its ref updating, but you're still passing it down, every time that its dependency is changing, its ref is changing, its reference is changing, which means that it might be a pure component, it's still going to rerun its render cycle because it doesn't know that the functionality hasn't changed. The reference has, and so you can get an unnecessary update even with pure components. And actually, this came about realizing that this was a backdoor sort of into pure components.
Fantastic, great. Well, yeah, thank you again on a really good talk. You survived. You survived the Q&A, which is often the hardest part as well. So it's Kannan's turn next. So Kannan, how are you feeling?
I'm feeling good.
Good. All right, great. Well, we'll let it take away.
Sure. Hello all. Welcome to Time to React. I hope everyone is safe and healthy. Today we are going to talk about atomic data-driven design elements. Let me present this. Hello all, welcome to Time to React. I hope everyone is safe and healthy. Today we are going to talk about atomic data-driven design elements. Let me present this. So this is Kannan Ganeshan, senior front-end developer at Simply Business. I do have close to 11 years of experience in front-end development and close to 6 years of experience in React development. I'm an active contributor to Stack Overflow, GitHub, and you can find me in LinkedIn as well. So as I mentioned, talk about atomic data-driven design elements, kind of a technical introduction towards it. Consider a requirement. Let's say I got a requirement to build sign in and register pages, two different pages with all the necessary functionality. So before start code, I used to think which approach is best for my development. This feature, which approach helps a lot in terms of future forecasting, like reusability, efficiency. So I'll take plenty of parameters to be considerable parameters that I'll take before start write code. In this presentation, I'm going to talk about 3 different approaches. From there, I will explain how atomic data-driven design elements helps a lot. Let's take a first approach. So this is kind of a traditional approach using React. I will have 2 different JSX file. Let's say login and register. Both will embedded into each different pages. Like login page will call login.jsx, where I will hard code each and every element. If you see, I'm hard coding the HTML tags along with their own properties like labels. I'm hard coding all those things. Register also. Let's say I'm not reusing anything, and I'm just hard coding all the informations. So there's a problem with this approach, because if you see, like, I'm repeating code. You can see like login.jsx and register.jsx. I'm repeating the same code of input, header, button, anchor. Let's say if I wanted to theme, then obviously I'll end up like a problem, because I'm repeating I'm duplicating the codes. And as I mentioned, like very specific components to each pages. Then I will end up like having a login page and register page. Then I will embed the components to be specific to each pages. Login page will have login component, and register page will have register component. There is no reusability. Let's say a new feature comes. Let's say I was asked to create a COVID form. Then obviously again I need to create a same form. Then again I'll end up like all the functionality. Let's say I will again need same effort. So there is no efficiency in the development. Inconsistency between components and view. Stale-get creation for UX become complex. Lack of precision in estimating development time, because I'm duplicating and each and every time I'm creating the same components again and again. Side effects: hard coding business logic on UI. This is one of the major problem. The reason is, if you hard code the business logics in the UI, then obviously any changes to the business logics, which frequently will change, we need to come and change in my front-end code. I need to deploy the whole application again and again, which is obviously painful. And as part of based on my opinion, I can say like front-end React is only for a presentation purpose. We shouldn't do any kind of calculation or computation on top of React. So it should be purely a presentation purpose. So the first approach has these kind of problems. So let's say an idea how we can overcome this problem. Because we are having everything as a specific to each components. Let's say take this example. Rather than having a login button, why don't I have a button? Rather than having a text box with a label, why don't I have a label and placeholder? Like this, I can generate generic components that I can reuse anywhere. Like I can create one time that can be reused like n number of different forms. Everything is linked. So once I have created my components, then I can move the components, which is a generic components. I can move it to anywhere, and I can create my own features.
By the way?
I don't need to repeat my code, or I don't need to do it again and again. This will save plenty of development effort for me. Let's say this is a kind of once I have done with my creating a library, list of components, generic components, then I will put it in a library, and anyone can pull that component and they can build their own UI. To achieve this, we need to go for the atomic design principles. We need to follow atomic design principles. So what is atomic design principle? It has 5 different phases. One is atom, molecules, organisms, templates, and pages. Atoms are a small component. Molecules are more than one atom. Organisms is more than one molecules, and vice versa. Like it will go tell templates and pages. This GIF will explain you how this is currently working. How the whole idea would be. So using these atomic components, I'm going to do my second approach. First approach is hard coding. Second approach with atomic on top of atomic components. So to achieve my requirement of creating 2 different registration and sign-in, I will end up having 4 different reusable components. So once I've created these 4 reusable components, I will be able to complete both registration and login pages. You can see, approach using atomic, I have a same 2 different JSX where you can see I have a label component, input component, link component, button component, which I'm reusing for register.jsx also. So I'm only changing the properties alone. The text and other things, and we can reuse everything. So this will reduce plenty of development effort, but still it has set of problems. Let's say as of now we got to overcome with a set of issues that we discussed for the hard coding approach. First one is inconsistency between components and view, which we got overcome, and repeated code, stale guide creations, no reusability, no efficiency, everything we got overcome. But we still have 4 more issues. Very specific component to each pages. So as I mentioned, obviously we'll end up 2 different JSX files, and this JSX file is specific to each pages. Introducing new feature using existing components require considerable amount of development effort. The thing is, if a new feature comes, then obviously I need to find out what are all the available components, and then I need to create a page, and I need to organize our current atomic components into the pages. So this will take a development effort. And also again, I'll end up hard coding business logics on the UI. You can see I'm hard coding the business logics, like business requirements or business text or label inside my component, such as welcome back, sign in to continue, email address, and forget password with the link. Everything is hard coded here. So as I mentioned, front end is only for presentation purpose. We shouldn't compute, or we shouldn't calculate, or we shouldn't do anything. We shouldn't hard code anything in our front end, which will obviously cause pain if any changes came into a particular component. And the last point is require front-end development for small changes on component as it's hard-coded on pages. Let's take this example. If business team, they are coming and saying they wanted to change the label for the particular sign-in login page and register page, then I need to go and change the name in my login.jsx or register.jsx, and I need to generate a bundle, and I need to push this code to server to make it live. So this requires considerable amount of effort, like code review and other things. Then obviously it will take development effort. So to overcome these 4 different issues that we have seen, third approach, which is a data-driven design elements. It's kind of a introduction, the overall view is a form or elements can be driven through data objects. Each atomic component can be pulled based on a data object within its properties. So in the second approach, if you see I'm having an atomic component and I'm hard coding those atomic component in my pages, rather than data driven design elements is something like you can, each piece of UI, piece of UI is called component. Each component can be called using data objects within its properties. So each piece of UI has its own key, and if you call the key, then React will serve the respective piece of UI. I'll explain in the further slides in a clear manner. Advantages: it increases productivity and reusability, allows us to keep isolating the business rules and front-end UI. So this is one of the major point, because we are not hard coding anything. Once you are done creating the components, then that's it. You will never touch it again. Server-driven user interfaces means we can modify and introduce new form of elements simply by adding and updating within the data. No need to touch the UI portion multiple times. So in this case, as this is data object, server can drive the UI. So server can decide what kind of a data that UI should present, and it can control entire user interfaces, entire UX behavior, server objects. So as I mentioned, everything is data objects. It's pretty easy to manipulate the data objects rather than going and finding the respective elements in the component and changing those. Obviously will cause plenty of pain. Then everything is data object. Manipulate the data to create dynamic UI is much more simple. Writing test cases is easy and no need to write for each pages of feature. So we are not going to write test cases for each pages or each features. We are going to write test cases for our components. So once we are done with test casing, creating a test case for our components, then we are done. We no need to worry about anything. So in this particular example, I have created 11 different data-driven design elements. These 11 different data-driven components were not tied up with any business rules. It's purely driven through data objects. So I'm going to show a demo on that. So using this approach, once I have done with developing these 11 components, then that's it. I will never ever touch my components again. I will expose the properties to the server team or any other team. Then they can directly utilize those properties and they can drive the UI. Front end, if any new feature or project comes, it's kind of a matter of minutes, like drag and drop. I can move the components and I can build the UX journey. I'll show you how that works in the upcoming slides. So as I mentioned, I created 11 different components, which is a data driven. You can see these objects represent the piece of UI that you're currently seeing here. Let's say it has a type header, which is unique for each component. Each component has its own type. Type is a key for us for React to identify and serve the respective component. And you can see these elements like image, text, label, everything is configured here. Let's say image, the image location, this can be any URL we can give it. We can dynamically change it. And the alt text, image position, whether we can display top, bottom, left, right, we can configure it. Text align can be left, right, center. Title, like business health insurance, and subtitle 1 or subtitle 2, we can have it. If we can even add accessibility parameters, like area parameters, and we can add tracking informations as well. So as this block of object is representing this UI. So that is what I wanted to highlight. And this one component can able to behave in different way. Like if I, as I mentioned, like the image position, if you move to top to left, right, you can see a different UX behaviors. And that align, text align will be center, left, right. We can create a number of different behaviors. Second component, select. Let's say, as I mentioned, similar to first component, you can see the type select is a key for my component. This visible, this flag is controlling whether to display the particular component or not. This is introduced for dynamic elements. And the field name, which is unique, placeholder, what you wanted to see, and the label, it can be, position can be top, left, right, we can configure it. So once we are done creating a component, then one component is equal to n different behaviors. So like if you have 11 components, then you can expect 60 to 70 different varieties of UI behaviors. So there are certain conditions, there are certain scenarios where I may need to introduce dynamic elements. Let's say when tapping one button, I need to introduce a new block of UI. So in that case, that can be achieved through preconditions. So we have a precondition and post condition in our data objects. I'll explain it while showing a demo. So I'm going to show a demo of Playground. Playground is something like a ground where the 11 components that I have created, how this works and what is how this looks like data driven, and what are all the advantage towards it. I'll explain that. So this is Playground. As you are seeing, like 11 components that I have shown in the slides were listed here, and you can see these. Each and every component is on molecules, and each component has its own properties. It's a property like data-driven design elements, and you can see I have created different UX behaviors using the 11 components that I have. So, as I mentioned, it's data-driven. I can see the entire data that, the elements that you're currently seeing in the UI. The data is currently available in the right side when you tap Playground. And also I can control each and every pieces. So basically, as I mentioned, there is no business rule tied with the component. This can be moved to anywhere. Like I can move it to top and bottom. The whole functionality remains same. Sorry. So let's say, as I mentioned, like we can control this, control the entire JSON. The entire page state using context, and we can control individual data driven component. So in this component, as I mentioned, like this is my properties. So let's say I wanted to change this data. So you can see, like I can change the value and I can see a dynamic user experience. This is much more useful for anyone, especially UX team, to find out based on the available components, they can able to generate their own UX experience. And this is much more, this is 100% achievable. And the subtitle also, I can remove it. Let's say test SMA health. And as I mentioned, I can add any image also. So this image, I can give a third party, like a direct link as well. So everything is data driven. And one more advantage towards this is, when I remove this image, it will behave like a title with subtitle. If I remove subtitle, it will be label. So I have one component which is label. That component is capable of behaving 3 different ways. So like this, anyone can generate their own form and they can build their own UX, user experience journey. So I have 11 components, and these components can be dynamically invocable, dynamically generatable. So if you see in my Playground, I didn't have anything right now in this page. Let's say I'm going to create a form. Creating a form for me is kind of seconds rather than hours or days. Let's say I'm going to create a COVID form. I simply tap a label, which will generate me a placeholder label component, and I need to input text, and I need one button. I'll go ahead and simply change the properties. COVID form. Please fill the details. This is much more useful for UX team and other business team to find out which is possible and which is an efficient, and it's kind of a we can deliver it in faster manner, because this is a data driven. Okay, so I'm going to change the name of my input. Let's say this is first name, and this is a last name, and this would be submit. Okay, so now I created a form, and I even have an action for the button. Everything can be configurable. Let's say there are certain scenarios where I may need to introduce dynamic population of elements. Let's say when user tap one particular element, I wanted to introduce a new element. In that case, let's take an example. I wanted to introduce a select button. I'm going to change this to sex, male, female. You can see the changes were really live, and you can edit the form and with the real live components, real front-end React components. Each one of them were molecules, React components. So as I mentioned, now I'm going to show last name only for females. So in that case, I need to simply map this with female. When you tap this, I'll show you how this works. When you tap male, the block will not appear. When you tap female, you will see this particular block. How this works? As I mentioned, you can see in the properties, precondition is generated. Preconditions is something like a mapping with the particular object. As this is an object, it's pretty more easy for a developer to map any field with any, first component with nth component or nth component with first component. The relationship can be easily built, and it is pretty more straightforward, and it's easy to understandable. So as I mentioned, like you can see the field name. The field name is a unique, as I mentioned, and the values female. So if you see the properties, the field name is select42, which will obviously generate, and it will populate, and it will map with the respective element, and it will be tied up with an element. So other than female, if you choose any options, the block will not appear. So this is one of the major advantage towards it. And as I mentioned, you can generate n number of different components. Let's say progress bar. You can see everything is configurable. Everything is configurable. Whatever you are seeing in the UI, everything is a data object. Data object can be easily manipulatable, and you can do whatever you want. And I have enabled HTML5 drag and drop concepts. Drag and drop, so that you can build your own form. So if you take a look of this example, I created a form like in 50 to 60 seconds, just configuring the respective images and text labels. That's all. Once you are done, simply tap a playground, which will generate the information towards your components. So simply copy this JSON data and hand over to server team. If server returns this response, then your React will return piece of UIs that you have currently seeing. So as I mentioned, this is a data driven. If server can able to handle the UI, let's say if I wanted to change the name, they can simply change the data here. They can see the changes in the UI. So this can be usable by non-tech people, not only tech people. Non-tech people can also able to understand, and they can easily play with this playground. That is what it meant, and this is what that is the main purpose we have created this playground. So I believe everyone is curious to know how this works. Let me quickly go over the code. I'm using create React app as a base, and I have created 11 different components that I have shown it to you in the playground demo. So this is my index application. I'm using a context to store my initial state. If you see my initial step 1, you can see the list of components where it's kind of hard coded. It's not hard coded. Like I have a default state which has all the data. As I mentioned, I'm using context. You can see the entire data which you have seen in the first step. The entire data that you have seen. For demo purpose, I did, but however, I have shown you like I can generate a number of different data based on the user selection. You can see simply by tapping, you can see in the right side the JSON is getting generated. Okay, so let me explain how this works. As I mentioned, I'm using context. And this is for HTML5, the drag and drop provider. And I have a form. This is the beauty. Like, I have only one form, and this form is capable of generating or supporting n different forms or n different elements, n different behaviors towards a UX journey. I'm not hard coding, or I don't have any step 1, step 2, step 3, or step 1 different pages. I have only one form. That form is capable of handling n different pages. So how this is possible? I'm using a lazy for importing my components in a dynamic way, which is much more efficient way. And I'm using latest hooks for handling my current step or next step and other things. The main key part here is this is where I generate the components. When user tap label, I will generate label like this for each things. This is the main part of my component. Element factory. Element factory is responsible for throwing a piece of UI based on the data objects. So it's kind of a factory. You give 10 objects or 100 objects, you will get served 100 different piece of UI. It's based on data objects. So if you see my element factory, it is pretty straightforward and it is pretty simple. That is what I want to highlight. It's not a complex algorithm or something. It's plain and pretty simple logic. So you can see I have 11 components. I'm using lazy import to load the component, and here is where I'm getting the whole context state object, and I'm passing the properties, and you can see like I'm mapping this with each key. It's a type with a component. You can see I have 11 components. 11 components keys are mapped with each keys are mapped with a component. I'm driving the entire functionality towards two different keys. One is visible, second one is type. This type is a key parameter, key determining parameter to show which component, to serve which component. So basically, if you give an object with a type text, this element factory will throw a text component. Like this one component will get 100 list objects. It will throw 100 different piece of UI. There is no limit for this. That is what I want to highlight. Yes. So this element factory, and let's go to the component. Component is pretty simple, pretty straightforward. It asks this is responsible for rendering a piece of UI. So as I mentioned, atomic components, these are the molecules. This is not an atom, this is a molecules. More than one atoms were tied up as a molecule. And I'm using prop type to make it to check whether the properties, whether the server objects is properly serving to render the piece of UI. So this is to ensure. And I have, as I mentioned, I have a store. Let's play with this store for a moment. So there is an additional advantage that I have added, like all the operations that the user is currently doing, as I don't have a backend service integrated, I'm storing that in my local storage, and you can see the data objects which was generated based on our interaction. So let me remove this. As I mentioned, this is a default initial state for my application. As of now, you can see like 6 steps I have. Let me introduce a 7th step. Let's say this step is test step. As this is data objects, when I save it, when I refresh this, you can see the 7th step. The step is test step. I can play whatever I want. So as I mentioned, like this is what data-driven design element does. This element factory is not limited. That is one of the major advantages. It's not limited. You can give like 1,000 or 2,000 component objects. You can get different user behavior, user experience. You can able to get it from the component. Let me explain important points to take away. First point, component property should be well defined and documented. This is one of the key points, because this components library is not only going to be used by developers, other teams also they are going to utilize. Huge impact on cross-team development effort. This is not only impacting an effort for the not only for the developers, it's also have a huge impact for UX designers, testers, and business peoples, because we have everything in a visualized library. So UX team, they can easily generate their prototype and they can hand over the data objects to server team. When we have 25 plus component, then it's more than enough to produce 100 different behaviors. Hence the productivity and delivery time would be super fast for new projects. Because I have a necessary component, that component is capable of behaving like in different way, then that is more than enough for me. I have a visual playground. I can see what my exact user experience will be. And one of the main pointers, UX team is not going to do something on the prototype. They are working with the real live components, the styles and everything which is supposed to be live. They are playing with the live components, for example. So this will be impacting their working way also. That is what I want to highlight. And visual playground library. As you have seen the playground, it's a visual playground library. Generate your own UX prototype, hand over the data object to server team. Once you are done, once you are creating a certain number of components, then you can simply hand over the playground to anyone. They can generate their own prototype. The main advantage is no need to touch front-end code. Write once and leave it. This is one of the key takeaway. Because front end, each and every time, like for small copy changes, I need to go and change my front end application, and the whole application needs to be compiled again, and then we need to bundle it and we need to deploy it into server, which will take plenty of others effort also, and for the developers also, which is kind of a bad. So in that case, data driven is something like a server side change. They can simply change the properties. It's a data object. It's not anything like, it's kind of a JSON object. They can change it, and server is driving the entire user interface. Number of pages, elements, behaviors, labels, etc. So front-end developer effort is almost zero. Let's say if a new component comes or new requirement comes, at that time front-end developer have to expose a property. That property can be utilized not only for the current project, that property can be used for new projects as well. That is one of the highlight. So whatever you do, it is a reusable one, can be utilized across our organization. So as we have gone through like 3 different approaches, this is kind of an approximate effort for each approach. For hard coding approach, I'll have you can see like overall 56 hours for my for this hard coding approach. As I mentioned, like UX designer, they need to design for each and every pages, each and every component, each and every piece of UI. So obviously their effort will go high. Front-end developer, obviously 16 hours for them, because they are hard coding everything. Any changes, they need to come back and they need to do it. Let's say a new requirement like COVID form is coming, then obviously they need again 56 hours for them. For the backend developer, it remains same, because they are exposing services. They are not doing anything on top of components or other things. Testers, they need to ensure the application is properly working or not, and discussion meetings will take much more time because everything is hard-coded. A small change, again they need to come for the discussion meetings, whether it is possible. Front-end developer need to confirm it is possible or not. So there are back and forth. We can reduce using data-driven these kind of meetings and discussions. Second approach is atomic design approach, which is most of our companies are using this approach, and this is much more time-saving approach. This is much more useful in a way, like for the front-end development. Like once I have done like 4 components, as I shown in the previous slides, I have only 4 components that can able to support 2 different features, 2 different pages. So front-end development is almost half, and the UX designer's effort will remain somewhat less compared to previous hard coding things. And backend developer remains same, because they need to write services. Testers will also remain same. Discussion and meeting will go bit down. The reason is we have only 4 components, and the changes will be much more less, because we are reusing styles and other things, because we are using atomic design on top of it. The third and final approach is data driven approach. So in this approach, you can see like front-end development effort is almost zero, for the reusing the existing components. UX designers effort is going bit like it's halfway below. The thing is, UX designers, we are handing over the library and they have the list of components, and they can play around it. They can assemble the UX and they can generate a prototype. It's not a prototype. They are doing what actually going to live. It's not something like they are doing some prototype and handing over the developer. Developers again need to steal anything. Nothing is there. They are the one doing development. UX team is doing a development. Once they are done, they need to copy the JSON objects and hand out to the server team. Backend efforts will remain same. Testers will be much more less because it's a data-driven approach, and tester needs to ensure if everything is working fine or not. Discussion as meetings is going much more low. The reason is this is a visual library and they can see what is working and what is not working. And as I mentioned, front-end developer is much more less. Like 1 hour is just an ensure whether everything is working fine. I mean, whether UX team is doing as an expected way, just to ensure. So this may be less than 1 hour also. It's kind of a comparison like approach 1, approach 2, and approach 3. So as you can see the differences for the approach 1 to approach 2, you can save some time. Approach 3, you can save more time. This is not effort for first time development, but in future, like if you do if you deliver like 2 to 3 projects, then fourth project, this 20 hours you will never, you may not need this 20 hours also. It will be go down. So because you have everything is ready, so it's like a live component which is ready to go. Anyone can assemble and they can generate their own UI. We need one server developer, simply push it, they can do. Like if you have like 50 components, that's it. Just simply sit. You can play with the playground and generate a JSON, give it to server team, they can do the rest of the things. So as this is data driven design elements, we need to ensure everything is working as expected. This is a crucial part of is testing. So testing suite, we are currently utilizing 2 different libraries. One is Jest and React testing library. In other words, we can call this a visual testing library because everything is in a visual manner. So the testing would be much more easy, and this will be helpful for us to understand how data driven is properly working. We need to ensure the properties are properly responding with expected UX piece of UI. That's it. Like if you have 10 properties, change it in a dynamic way and expect a proper piece of UI is returning or not. That's it. So type of testing that we are currently focusing is functional integration, component-based testing, snapshot-based testing. This testing is more than enough for us to ensure our data-driven components are working perfectly. So I hope everyone got information about data-driven approach. If you have any questions, please do let me know. Thank you.
Okay, we're back. Thanks very much, Kannan. That was brilliant. That was very, very good. And apologies to everybody for the issue at the beginning, the technical issue. Apparently, they happen when you're doing live shows. I don't know if you have any questions around the topic, Elliot.
Yeah, I definitely have some. That was really great. Thank you, Kannan. It certainly provoked a lot of conversation internally with us. I've got a Teams chat that's going off the rails at the moment of people thinking about how we can apply this sort of thinking. One thing that I actually was thinking of was the preconditions I really like as a way of encoding conditional logic into the database form. Have you kind of considered extending this with like a functional pattern or anything else to support kind of more conditional logic options?
Yes. So basically, as this is a data-driven, there are 2 things that one thing I haven't explained, like is a post condition. there are two things. One is post and pre. Precondition is something like while rendering the form, we need to ensure the elements are properly working, and the initial set of actions, I mean, without invoking an API call and doing certain things, will be handled on preconditions. Let's say I wanted to trigger some an API call. From the response of the API call, I wanted to do some set of element, introducing a new elements and something like that. Then we need to introduce those into a precondition array. So as is data driven, it provides much more flexible for us to introduce a new change to our form. Let's say if I wanted to, let's like an example, a label. If I wanted to show a different behavior in my label component, then introducing additional property will help me to serve that particular piece of UI. And this property is not only tied up with the new requirement. This property can be used across even old projects and new projects and upcoming projects. So one property can be utilized in multiple ways. That is what.
Yeah, that's awesome. Actually, the idea of sharing that functionality around.
Exactly. So even we can introduce additional flag, and we need to be much more careful. Like when we go like beyond, let's say if one component cannot have multiple complex operations, in that case we need to split that into 2 or more components. Let's say a text box can only handle like 5 different varieties of UI. We shouldn't enforce to handle like 20 or 30 different UX. Then the component will be much more complex. So in that case, as I mentioned, type is a key. Then we can add an let's say additional text box with a different action. We can differentiate using type, and we can pick the respective component. So as this is a molecule, we can even utilize the existing text component as well. So this will so we shouldn't make a component much more complex. As is data driven, we should be much more careful on the properties.
Awesome, absolutely. And where do you kind of see the edge cases of the system, when like the points when you start to need to write new components or add new bits of logic to create more kind of custom form design?
Exactly. So that's a great question. Actually, let's say I have a component with like 10 to 20 properties tied up with. If there is a new requirement, first I'll check whether my properties, as I mentioned, like we have a visual library where we can find out all different properties which was already exposed and documented. And we will just change it, and we'll see whether this is an expected UX portion that I need. If that is not the case, then I need to expose a new property. Before exposing a new property, I need to ensure that the property doesn't exist, or no component is serving that particular behaviors, I mean UX behavior. Then as I mentioned, like I need to check the complexity of component. If the complexity is already high, then I need to skip that component, and then I need to introduce a new component. So this is the data driven. From the front end, I need to create one component and I'll leave it. That's it. I'll create test cases for that and leave it. I'll do all the necessary things like introducing the properties and other things in a server side. Like they are already serving a JSON data, I mean data objects. They will additionally introduce a new properties in the data object. In future, if they want, they need to add the same into some other service. Let's say sign in page service. Rather than they wanted to do it in a new service such as registration service, then they need to simply add the property. That's it.
Awesome. That's great. I'm just having a little look through the comments here. Tons of praise coming in for the presentation, Kannan. Obviously, a lot of people found it really, really valuable. Just one question though as well from Dimitri. He says, we're using our own design system tool, he's using their own design system as well, but they organize it using Storybook. What are the advantages of this over Storybook?
Yes, that's also a good question. So basically, Storybook is something like to see your component in a visual way. Like based on the properties, you can play it and you can see the visual way of how your property will be, how your component will behave. But Playground is one step ahead of Storybook, where Playground is a visual treat of, it's kind of a visual treat of how the form would be in a, in live, I mean, in an actual live. Because it has its own properties, we can obviously play with the properties, and we can arrange it, which doesn't Storybook doesn't support. We can arrange it, and we can see a visual form, and we can execute the form. In Storybook, it's kind of it requires some additional effort where we need to configure storybook.js for the particular component. We need to write it. Whereas Playground is something like it will get all the properties which is coming towards my component. As this is a molecule, I will expose all the components, expose all the properties coming to my component, and we can play with the properties. So in case if I introduce a new property also, I simply go in the Playground, I can see the new property. Whereas in Storybook, I need to add support for the new property so that I can see the visual. So basically, Storybook is kind of a plain visual for isolated components, whereas Playground is a visual treat of more than one component, and you can do all the things. And the main purpose for Playground is this can be consumed by non-tech people such as UX designer and business peoples, rather than so basically React is kind of technology. It should not restrict with developers. It should be usable by all the different varieties of teams, because they are also part of team, and they do have enough rights to play with the UX element, and they can generate their user interface, which was much more useful for a company perspective, and it reduces plenty of effort, which I would definitely say.
That's awesome. Nice. Thanks, Kannan. I think that's it for tonight then. It's been really, really good having you both. Thank you so much for giving us your time. Thank you to everybody who's been watching as well, because we always really love having the community still engaging with us, still coming down for the talks, just virtually. And we really appreciate the quality that you guys are providing. It's really, really good quality stuff. So big thank you from me, and a pleasure to see you again as well, Elliot. Hopefully we'll get you to do another talk soon, but maybe you'll be back in an actual venue as well next time.
Fingers crossed.
Yeah.
Thanks for watching, everyone.
Yeah, thank you very much. I'm going to pass you over to Duncan, and he'll see you guys out. So thank you, and we'll see you next time. We have more events, more live events this week, so you can find out more about them on the channel. Yeah, we'll see you next time. Thank you.
Thank you. Bye.
Well, that's the event for us tonight then, guys. Hope you all really enjoyed it. Thank you for joining me in my sushi shop background. If you missed it at the start, that's a joke. It's not a sushi shop. It's my room divider, which I had the choice between a white one and this one, and I somehow went for this one. And every single Zoom call, I have to explain it now, even for people who've seen it before. They still like to laugh, but I'm happy to bring a smile to people's faces. So yeah, thank you very much to Elliot and the guys over at Hyperexponential for taking the time to both market this event, and Elliot for putting together presentations. Really awesome. And then thanks so much to Kannan and the guys over at Simply Business. Again, really, really great event. So hope you guys really enjoyed it. We will be looking at doing this a bit more regularly. I know that we've already got a couple of speakers lined up for September, but if you are interested in speaking at our October event, then yeah, please just reach out to me. If you've got questions about Hyperexponential or Simply Business, or just wanting to continue the conversation that the guys spoke about in their presentations tonight, then you can reach out to Elliot and Kannan directly. And then yeah, if you have any questions, anything like that, any comments, any feedback on how we can do these things better, then please just let me know. But for now, thank you so much, guys. I hope you enjoyed the event, and we'll see you in September.